Okay, boys, the chapter elasticity. Yesterday, we started the problems. We did number one, and I gave some numbers for you to try. Tell me which number you want to ask me from page number 380. Do you have any number to ask me? Say fast.
So 9.
Yeah. Question number 9. Before number 9, any question? Before question 9, we have any other? Or we straight away do number 9?
So 4.
Okay, 4. Before 4, any number? Give me the number which comes earlier first. If you have to ask me. If it is okay, then give me the earlier number first. Okay, before 4, you don't have any, Yes? Yeah, tell me fast.
Yes, so
Decide
okay.
and tell me. Okay, no, number 4. Okay. Question number 4. Two wires A and B made of different materials have the same length, but wire A has twice the area of cross section and than the wire B. Young modulus of wire A and B are also given. Calculate the elongation produced in wire A when subjected to a force of 2 kg weight if the elongation produced in wire B under the same force is 0.072 millimeters. Okay. This question they are saying the two wires having same original length. What is the formula? We know the formula y is equal to the formula goes like this, F by A delta L here divided by L. In this question, what are the things different? We'll check it. Young's modulus is different. Force is same. Original length is same. Area of cross section is different. So I'll be writing at least right here for two wires. For two wires, we write the formula is y1 is equal to y and A are inversely proportional, right? Like A2 by A1. Y and delta L is again inversely proportional, and write delta L2 by delta L1. A and L we will not write. Y1 by Y2 ratio. I write like this. Ratio wise I'll take. Y1 by Y2, this is for, 1 is for the wire A and 2 is for the wire B. Same force we are applying and they have got original length same, both the wires. But Young's modulus are different, area of cross section is different and elongations are different, that we have to find. Okay, now I'll put the value. What is the Young's modulus of the wire A given in the question is how much? 1 into 10 to the power of 11. 1 into 10 to the power of 11. Y2 value is how much? 1.8 into 10 to the power of 11. Area of the second wire. First wire is double the area of the second wire. We are saying that. The wire A has twice the area. That means when A2 is 1 unit, then A1 is 2 units. Okay. Elongation in the wire B, that is delta L2 is given. In the question it is given 0.072. 0.072. You have to find the value of delta L1. Now get the answer. These two will cancel. I think you can find the answer. 2 and this will go 0.9. The delta L1 answer is coming 0.9 into this. 0.9 into 0.072. Check. Check your answer. Answer will come 0.065. Same unit. We will give the same unit. Both of them will have same unit. What is the unit given in the first case? Millimeters. So this also will be millimeter. Same unit. Because we are doing it ratio wise. So ratio time we can keep the same unit. This is answer. Check 0.9 into this. You get this answer 0.065. You will be getting this answer.
Yes, sir, correct.
Yes. Okay, now after that, which number? Tell me after this, which number?
Sir, 9, no? 5.
Number 9. Huh?
Sir, 5.
Say fast. Okay, 5.
5.
Okay, I'll do number 5. Number 5 now. For steel, the breaking stress is 8 into 10 to the power of 6 Pascal and the density is 8 into 10 to the power of 3 kg per meter cube. Find the maximum length of a steel wire which can be suspended without breaking under its own weight. Okay. G value is given 10. Breaking stress given. What is the formula of breaking stress? Or stress formula is what? F by A. So let us write that. Breaking stress is equal to F by A. Next time we can continue this side. F value G is given. Own weight they are saying. Own weight. Okay. Area not given, so I'll keep as it is. Mass will be volume into density, and volume will be area of cross section into L into density G by A. This A and A will go. It will come L rho G. Rho is the density. This is the value of breaking stress. Write down here breaking stress. Breaking stress. Now I put the value. Breaking stress value is given in the question how much? 8 into 10 to the power of 6. Write down that value. 8 into 10 to the power of 6. You have to find the length of the wire. Density of the wire is given 8 into 10 to the power of 3 and G value is given 10. Now get the answer. Get the answer. I think answer will come 10 to the power of 2, that is 100. 100 meters. 8 and 8 cancelled. 10 to the power of 3 and 10 to the power of 4 and this. 10 square is left over. 10 square means 100. 10 square answer is 100.
Sir, breaking stress and normal stress are same.
Same. Stress means same only. No. Stress means same only. Stress formula is only F by A.
Okay, sir.
Okay. But the main thing is now how to arrange because area of cross section not given, they have given density. You have to express in the form of given quantity. So I express mass is equal to volume to density. Volume formula I wrote area of cross section into the length. E and A cancel now. That's why area we do not need and it is not given also. So we don't need. So accordingly we have a final answer. Now which number now boys we said? Number?
Sir, 9.
Which number? Number 9.
Sir, and hint about 8 also.
Okay, hint about it. Okay. Hint about it. Calculate the increase in the energy of a brass bar of length 0.2 meter and cross sectional area 1 centimeter square when compressed with a load of 5 kg weight along the length. Y for brass is given and G value is given. Okay. Question number 8. Have any one of you done this question number 8? Tell me, any one of you? Have you done it? Young modulus and all given and they're asking find the increase in the energy. That means they're talking about elastic potential energy. What is the formula of elastic potential energy? Tell me, what is the formula of elastic potential energy? Write down the formula. Elastic potential energy formula as I given half into F into delta L. Please check. If you don't know, please check it. Elastic potential energy formula is half F delta L. Please turn over the
Yes,
page
sir.
and see. Okay, in this question, force is given 5 kg weight. Okay, F value is given 5 kg weight, which we will change into Newton. Huh? But delta L is not given here. Elongation not given. We'll find elongation value using the formula of Young's modulus, Y formula. We are ultimately using this formula only, but delta L we have to find by using the formula Y. What is the formula Y? F by A into delta L by capital L. What we can do, we'll make delta L the subject. Delta L is the subject of formula. It will become SL by AY. I'll put this value here back. Then I'll put the value ultimately now. Therefore, potential energy value will come half S delta L value. I'll put this value. What is the value coming? FL by AY. Now I'll put the value and find the answer now. Half F and S become F square. What is the value of F given here in the question? 5 kg weight. We change into Newton. That is 5 into G value is given 9.8. The value of F is coming 5 into 9.8. Again F is coming. So I can put a square here. I can put a square. Because F and F is F square. L means the original length. What is the original length given? Original length is given 0.2 meter. Right, 0.2 meter divided by area of cross section. What is the area of cross section given? 1 centimeter square. 1 centimeter square we will change into meter square. SI unit. Centimeter to meter. Well, that's 10 to the minus 4 because the square is 10 to the minus 2 whole square will become 10 to the minus 4. Changing in meter square. Into Y. Y is the Young's modulus. What is the value of Young's modulus given? 1 into 10 to the power of 11. 1 into 10 to the power of 11. Now, verify what is the answer coming here. Check with your calculator. And your answer will come 2.4 into 10 to the minus 5 joule. This is the answer coming. Please check. Check your answer. Check it. This is answer coming 2.4 into 10 to the minus 5 joule. Please verify and see whether the answer is correct or not. Verified.
Sir, doing.
Yes. Okay, do. You people did not know and you are just jumping. Huh? You are asking me number 9 and none of you knew it, how to do. Don't jump. Ask me sincerely if you have not done or you tried and you did not get. You are just jumping. Huh? Number 9 you are asking and you did not know number 8. Who of you knew it beforehand? Before I did know, who of you knew it?
So coming
I think
correct.
none. Uh, but you were asking me number 9, huh? You were just skipping this and you did not know the way. So you check carefully whichever you are not able to do or you will not be able to do. You ask me that, I'll give at least a hint or maybe a solution. Okay, number 8 is done now. Main thing now, you have to make the equation in the form of given quantities. Whatever quantities are given, no, all the information must fit. So that way you have to change the formula. You have to derive the relation in that format. Okay, now which number now? Number 9. Before
Yes,
that,
sir.
you can, I take for granted that you can do. Number 9, you're asking me now. Okay, a copper wire 2 meter long is stretched by 1 millimeter. Okay. If now the wire suddenly breaks, does its temperature increase or decrease? When you are stretching, that means what energy are you storing? Potential energy, elastic potential energy. And that potential energy will change into the heat energy. That will produce, because when you expand now, that there will be some heat generated. When the heat is produced, because potential energy is changing into elastic potential energy is changing into the heat energy you supplied, definitely the temperature will increase. You say for this question the temperature will rise. And now question is asking calculate the change in temperature. Okay, how to find the change in temperature? So we'll be writing like this: potential energy is equal to heat energy. Equate heat energy. Equating. What is the formula? Potential energy half F into delta L. Heat energy formula, let's have mc theta. You have to find the value of theta here. Class 10 formula mc theta, mst or mc theta. Mass into specific heat capacity into temperature difference. Okay, here we will see the information. They have given y is given. Okay, and elongation given 1 millimeter. Delta L is given, but S not given here. S is not given. What can we do now? Since S is not given, I will do what is the formula of Y? Young modulus is given. Young modulus formula we have got S by A delta L capital L. So make S the subject of formula F. The cross multiply you will do. Now when half F value I'll put here Y A delta L by L into delta L. This delta L. This is the value of F. This is the value of F I have put from this equation. And they have given density. So I'll change mass is equal to, I write volume into density. And volume is equal to, I write an area of cross section into the length. Here I write area of cross section into the length, capital L C theta. This A cancelled. That is why A is not given in the question. A is cancelling, so we do not need. Now I'll put the value. I think all the values are known, right? Half Y young modulus value. What is the young modulus value given? 1.2 into 10 power of 11. 1.2 into 10 to the power of 11. Elongation is given stretch by 1 millimeter. Change in meters. You get 1 into 10 to the minus 3. Delta L become whole square. L. This L and this L will be L square. What is the original length given? 2 meters. So here you can add 2. This side will add 2 into C value, specific heat capacity. But we'll take the value in kg per Kelvin, joule per kg per Kelvin, 0.42. That you have to multiply by 1000. This will become 420 joule per Kelvin into theta. Now, using this equation, get the value of theta and tell me what is the value of theta coming. Calculate. Calculate the value of theta. The value of theta is going to come like this: 1.2 into 10 power of 11 into 1 into 10 power minus 3 whole square divided by 2 to the 4 to the 8. 8 into 420. Now check. Use calculator and tell me what answer do you get. One thing I forgot to do, mass is equal to volume to density. Density I did not write. Please, little correction. Density is also given the question. Density I forgot to do. Density is given 9,000. So please density you write here 9,000 into theta. I forgot to put the value of density. That means divided by 9,000 also here. Mass is equal to volume into density. Volume is area of cross section into the length, into the density. Density I had forgotten to write. I am writing it now. Now check your answer. Density is also given in the question. No, I must put the value of density somewhere. I'm putting the value. Check your answer. What is answer? What is it? What is it? What's the answer?
So doing.
Okay. Done. Yeah, come on, boys. Tell me the answer. You must have got it. Yes. What is it? Okay. Nobody saying. What is the answer, boys? What is the answer? Yeah.
Calculation getting too lengthy.
Boys
So
are
doing.
quiet. Okay. You can see the answer in the book also it is given, no? Finish. What is the answer? The answer will come 0.004, 0.004 degrees Celsius. It may come 39 and all, so you can round off and write 4. 39 will become 4. 40 actually, so you can add 4. Check your answer. What is it?
Yes, sir.
What answer did you get? Exactly. Tell me. 0 point or 3.9 into 10 to the power of minus 4, something like that. Okay, now this one you can, I have written the answer. Answer will come 0.004 degrees Celsius. Okay. Now some questions you need to try, okay, yourself. Examples which you have to do by yourself. Okay, example 21-6. Example 21-6. I'll give some for you to try at home. Example 21-6, 21-7.
Page number.
Page number, see in the book it is given, page 372 and 373. 372. Okay, example 21-10, 21-10 and 21-11, 21-11. Do this much only, this chapter is done. These problems, examples, no, you'll try it yourself. Solution is also given, you can see the solution. If you don't understand, you'll ask me.
Sir, hello, sir.
Yes, yes.
Sir, I have a question.
Okay? Yeah.
Sir, is tension a vector quantity?
With tension?
Sir, surface tension is a vector quantity.
Surface tension is vector. Force per unit length. It's a kind of force.
And moment of inertia?
Inertia is like mass only, it is scalar.
Okay, sir. Thank you, sir.
Surface tension I haven't taught. Why you are worrying about that? After this
Sir,
we will be
just
doing
asking.
that chapter only, sir. After this we will be doing surface tension. Okay. And after surface
Okay, sir.
tension, we will go to oscillations, waves. Okay. After finishing waves, then we will be starting